Okay, so on the paper that I sent for 3.1, well, we have Q3 over here. For 3.1, they're saying, given that 13 cos B equals to 5, so we're given that 13 cos B beta equals to 5, right?
Yes, ma'am.
And A plus alpha plus beta equals to 90 degrees. Alpha plus beta equals to 90 degrees, right? By making use of a sketch and without the use of a calculator, calculate for the value of tan beta divided by cos alpha, right? So they're telling us that we have a 13 cos B, which is equals to 5, and alpha plus beta that is equals to 5. So once they tell us that we have something like this, remember cos, it's given by what? Because it's k. It's given by adjacent over hypotenuse, right? So if we're given cos, 13 cos beta equals to 5, we should thrive to make this cos, whatever it is that, right, try and make it a fraction. And the only way in which we can make it a fraction is if we divide both. Hey, man. Can I put my paper like this? Can you still see?
I can't. I'm not sure if I can like rotate my
Oh, you
screen.
can't rotate. Ish. Yeah, great. Let me just switch my position. Okay. So you see, we have 13. Wait. Uh, we have 13 cos B, right? So in order to
Yes,
make
ma'am.
this a fraction, we'd have to divide both sides by 13. So we can only be left with the cos beta. So now we have cos beta divided by 13, right? Hey, I'm lying. Cos beta equals to 5 divided by 13, right? Because we divided both sides by 13. You understand what we just did here, right?
Yes, ma'am.
Okay. Now you can easily plot this. Because remember, they said provide a sketch. So when you provide your sketch, it has to look like this. Trying to find. Oh, I wish I can sit here. Yeah. Remember, we said cos is what? It's adjacent over hypotenuse. We know that the adjacent, it lies on what? On the x-axis, right? So look positive by a positive, which means our x-axis, this 5, it should lie on the positive x-axis. Can you see that? Because had it been a negative, that's when we'd know that the sketch is going to be on this side. But this 5, it's a positive, so the sketch is going to be on this side. Can you see that?
Yes, ma'am.
Okay, so we're going to have like this. And we know that we're given the angle. This will be beta, right? So if this is beta, remember we said that cos beta equals to adjacent over hypotenuse. So we know for a fact that this is this is the adjacent, right? So it will be a 5. And then we have the hypotenuse, which is a 13, right? So what are we lacking? We don't have this side. What can we do in order to get this side?
Theorem of Pythagoras.
Exactly. And what state the theorem of Pythagoras for me?
Like the formula.
Yeah, the formula.
Again, R squared is equals to N plus Y squared.
Exactly. So in terms of this, what are we looking for? We're looking for the y, right?
Yes, ma'am.
Okay. Now, what is our r squared in the sketch?
The 13.
Exactly. The 13 squared equals to, it'll be the
The
5,
5.
right?
Yes, ma'am.
5 squared plus y squared. Now, in order to make the y the subject of the formula, we can easily just transpose that to this side. So we will have 13 squared minus, close bracket, 5 squared equals to y squared. Please put this into the calculator for us.
144.
144. One, 144 equals to y squared. Now, because this is squared, it's still not y. We can just what? Introduce the square root, right? Because the square
Yes,
root
ma'am.
will cancel this power over here. Now we'll have therefore y equals to, what is the square root of 144?
12.
12. Good. So which means this side over here, it's what? It's 12. Right? You get that, partner?
Yes, ma'am.
Okay, now let's revert back to the question. They said calculate the value of tan beta divided by cos alpha. So they said get tan beta divided by cos A, right? Now, when you look at this is our beta, right? Wait, let me just do this. This is our beta. If you try and get your tan beta, remember what is tan? Tan, it's just simply what? Tan is sine beta divided by cos beta. So when you're trying to get 10, okay, this is equals to 10. So when you're trying to get your 10 beta, you'd have to solve for this, right?
Wait, ma'am.
Yes.
That part I don't get. I don't understand the sine beta over cos.
Oh, okay. So this is like, what do you call it? It's an identity. Remember, we have an identity that looks like cos squared x plus sine squared x equals to 1. Hello?
Yes, ma'am.
Okay. I don't know if we have touched on identity. We actually have, when we were doing trigonometry, we said under our identities, we have our two most important identities. This is our identity one, which is cos squared x plus sine squared x equals to 1, right? And
Yes,
then
ma'am.
we also have tan x equals to sine x divided by cos x. These are like givens. You are supposed to know them.
Okay.
Okay. So these are the things that you're supposed to know. Ne?
Yes, ma'am.
So, as I was saying here, tan beta equals to sine beta divided by cos beta. So try and find out what our tan is. So when you try to find out what our tan is, you just have to say sine beta divided by cos beta. I'm coming. Oh, no problem. Okay, sorry. So yeah, try and solve what your 10 beta would be so that we can.
Since ma'am,
Yes.
since 10 is opposite over adjacent, would you say 13 over 5 or no?
Since 10, it's what? Opposite
It's
over adjacent.
yes, ma'am.
Wow. Yes, it is going to be 12 divided by 5. That is going to be our 10.
Okay.
So 10 of beta, you are correct. Uh, flipping out, flipping out, flipping out. Okay, wait, man. I'm trying to resolve this right. Um, in a minute. Okay, which one is better? Is this better? But I feel like from here it has like some darkness. Or is this better?
That one is better.
This one, ne?
Yes, ma'am.
Okay. So we are agreeing that 10 of beta, because from our so per toa, we know that tan is what? It's opposite over adjacent, right? So it's
Yes,
going to
ma'am.
be when we're at beta. Oh, no, wait, before that, remember this is 90 degrees and this is going to be alpha because they just told us in the statement that we have an alpha and we also have a beta in the 90-degree angle triangle. So this is our alpha. Ne? Provided that they don't state this, don't make this angle over here alpha. They only have to tell you this. That's when you can conclude that this here is alpha. Ne?
Yes, ma'am.
Okay, so we said 10 beta, it'll be opposite, which is 12, over adjacent, which is 5. So we're going to have 12 divided by 5, all divided by what is our cos alpha? Can you
Um,
check what our cos alpha? Yeah,
12 over 18.
correct. So it will be 12 over 13. Wait, let me check. Why are you the only one joining today? Where are people? Okay, fine. So now that we have it like this, it's a division, right? That's proper because they wanted it like this. But now you cannot perform any operations if it's like this, right? So we have to further simplify this. Remember, if you have um A divided by B, all divided by uh let me just say 2a and b. And now if you want to now make this a multiplication so that they can be besides one another, right, you're going to say a divided by b multiplied by whatever that was in the denominator, it now becomes the numerator. Whatever that was the numerator now becomes the denominator. So now you're going to have a divided by b, which is this part, multiplied by b divided by 2a. So now can you see you just swapped what the numerator and the denominator were over here?
Yes, ma'am.
Okay, great. So same thing will apply over here. So what I just said here, please apply it here. Let's see, what would we have over here then?
It would be 12 over 5 times 18 over 12.
Yes, correct. 13 over 12, which is now easier to work with because if we just have 12 over 5 times 13 all over 12, we can see that these two will what? Will cancel one another, right?
Oh, yes, ma'am.
Yes, exactly. They will cancel because they're the same. Now we'll just be left with 13 divided by 5, right? So
Yes,
this
ma'am.
will be our answer, our final answer. You get it?
Yes, ma'am.
Okay, beautiful. Now let's go to 3.2. So this is now where we're going to let me go to the question. Practice our reduction method, right? Mm. Okay, grade 11. Okay, so we're given, they're saying simplify the following. Okay, simplify the following to a single trigonometric term, right? So we have 3.2. So they're saying simplify into a single trigonometric. So we have sine 180 plus x multiplied by cos squared 90 minus x plus sine negative x multiplied by cos squared 180 degrees minus x, right? So they're telling us that we should simplify it into a single trig form 10, right?
Yes, ma'am.
So now let's look at this over here. Remember our cast diagram? We had the cast diagram, right? We said that this is ish. Let me properly draw it like this. Né? We said that this is our cast diagram. This is 0 degrees. This is 90, right? So this is 180. This is 270, and this is 360. This is the first quadrant. How do you write first? First. This is the second quadrant, third, and the fourth. Right. In the 0 to 90-degree quadrant, which is basically our first quadrant, this is the 90 minus x. And all the trig functions here in the first quadrant are positive because this is just all. All trig functions are positive.
Yes, ma'am.
Right. Now we come to the second quadrant. This is from 90 to 180, which is 180 minus theta. This one is our 180 minus theta or 180 minus x because I put an x here. Should have put an x there as well. But in the second quadrant, only sine it's positive. So if we have sine 180 minus x, we know this is going to be a positive sine x. But if we have like a cos 180 minus x, we know that it's going to be a negative cos x. You get it, ne?
Yes, ma'am.
Okay. And then in the third quadrant, only 10 is positive, and this is the 180 plus x quadrant. And in the fourth quadrant, only cosine is
Wait,
positive. Sorry?
ma'am,
Yes?
ma'am, at the 10, why is it plus x?
Because remember, do I have space this side? Yes. Okay. Okay, I'm gonna draw a test diagram over here now and make it big. This is 0. This is 90. Sorry. So anything from that's going that anything that's in between, anything, sorry, that falls in the first quadrant, it is less than 90. Do you agree
Mm.
with that?
Yes, ma'am.
I mean, if you have an 85, it's gonna fall here. If you have a 45, it's gonna fall here. If you have a 89 is gonna fall here. But notice that they are all less than 90. The 90 it's the boundary. Now we
Mm.
have, so which means here we have what? 90 minus x, right?
Yes, ma'am.
Okay, now we come to this one. Now it's from 90 to 180 degrees. Okay, I'm sorry, I have flu now. So from 90, okay, so from 90 to 180, these are the angles that are greater than 90, but they are less than 180. So your 95, you're going to get it here.
Mm.
Your 170, you're going to get it here. Your 120s, you're going to get them here. They're greater than 90, but less than 180. Right. So which means over here, when we write this over here, it's going to be 180 minus x. You understand? Like it's
Oh.
180 minus x. You understand this, ne?
Yes, ma'am.
Now, when we come to the third quadrant, this is between 180 and what? And 270. So your 260s, you're going to find them here. Any number that's greater than 180 but less than 270, you're going to find it here. So this is the 180 plus x quadrant because they're greater than 180. You can say 180 plus 40, it'll be here. Do you get
Okay.
it? Okay.
Yes, ma'am.
Wait, so the people in the group, I'm supposed to send answers to them, ne? If I'm writing like this, they won't understand. I-
Maybe they'll join at a later time.
Yeah, I'm just saying if I write gibberish like this, let me just write properly. Then now we're on this quadrant. We know that this is 360, a full revolution, right? So if it's 200 and 360, it means that everything that's in between 200 and 360, it will be here. So this quadrant over here, it's just 360 minus x. Do you get this? Like now, do you get all of these things?
Yes, ma'am.
Okay. And sometimes this one also it's written as 90 plus x, but normally it's when we're dealing with The other day I heard their names. Is it complementary angles? Hmm. What are those ones called, whereby you have cos, okay, let me just say, whereby you have sine 90 plus x, and then we say this is equals to cos x. What are these called, Kana? Are these complementary?
I think it is, yeah.
Yeah, yeah. So we normally see this one when we're dealing with these, right?
Okay.
So let's go back to our question. So we're saying we have sine 180 plus x. We have to check what's happening to sine in this quadrant over here. And which quadrant would this be? The 180 plus x? It's the third quadrant. And which trig function is positive in the third quadrant?
I don't know.
Okay, look at this, ne? This is the first quadrant. This is the second quadrant. This is the third quadrant. This is the fourth quadrant, right? And we have
Yes,
our
ma'am.
test. Remember our case we said here, all trig functions are positive. Here only sine, it's positive. Here only tan, it's positive. Then in the fourth, we said what? Cos, it's positive, right? So I'm
Yes,
saying
ma'am.
we have sine 180 plus 180 plus x. So for some reason, our sine function, it's finding itself in the
Oh,
third
and
quadrant because
10.
this is the 180 plus x quadrant, this one over here,
Yes, ma'am.
right? So how is sine behaving here? Oh, no, 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 that was not my question. My question was in the third quadrant, which trig function is positive?
10.
10, correct. So which means sine 180 plus x, it will be what? It will be a negative, right?
How come?
It will be negative because if we have sine
Oh,
180 plus x,
okay.
it means that sine is in here. Sine is
Yes,
not
ma'am.
supposed to be here,
Yes,
right?
ma'am.
Yes. So it means that now we have a negative sine x, right?
Mhm.
You understand this part again?
Yes, ma'am.
Okay. Negative sine x multiplied by. Remember what I said? I said we have, what do you call these?
Wait,
We
ma'am,
have,
the 180 you don't include it
no,
or
you don't include it. It's just
okay.
180. The 180, it's just the 180 plus x. It's to direct us, basically to take us to where, like, where on the Cartesian plane our sign is going
Mm-hmm.
to be, right?
Okay.
Now, yeah, we have this over here. This is the thing that I was talking about. Let me just, I wanna get the exact thing. What are they called, dog? Complementary angles. These are the angles. Yeah, they're called complementary angles. They're angles whereby um you add A plus B. They give you. Let me just get them. I just have to scroll. Wait, now. Just give me a few minutes. Oh no, they're called co-functions. Ne? They're called co-functions, not complementary. Yeah, that's what they're called, co-functions identities. Ne? So for
Yes.
co-functions identities, I don't know if you remember, but from last class, we said sine 90 minus x, it will be equals to cos, cos x, right? And cos 90 minus x, it will be equals to sine x, right? And
Yes, ma'am.
and uh, wait. Wait.
Ma'am, I just wanted to say, from last week, I wasn't here for the extra class, and the video, I
Oh,
couldn't watch it because I deleted my social media.
oh, so you don't even have YouTube as well?
Sometimes, like, I only watched the first few minutes of the video, but then I had
Oh,
to stop because I had to study for other tests.
yeah. Oh, okay. So you're basically learning for okay. So I'll give you grace. I was not aware. Nah. Let's keep.
It's fine, ma'am.
So we have what we call co-function identities. Co-function identities are basically wait, let me just write the other one. We have sine 90 plus x, but I'd suggest you go watch that video. Nah,
Yes,
maybe
ma'am.
like throughout the weekend. Because I know it's long, it's like 2 hours. Maybe spread it out. Maybe watch 10 minutes, 10 minutes, 10 minutes, but make sure throughout the weekend you're done with it, nah? Because
Yes,
you
ma'am.
don't want to get into the new week. Because next week we're doing something entirely new. We're going to be doing functions.
Mm. Yes,
Okay.
ma'am.
So, and then cos 90 plus x, it will be equals to. Wait. Okay. Minus sine x. Okay, let me do this now. Okay. So what we call co-functions, right? So co-functions are basically two functions, sorry. When you add them together, they give you 90 degrees. That's what's believed. Like it's identities. Same thing as the 10 beta being equals to sine beta divided by cos beta, or that one of cos squared x plus sine squared x equals to 1. These are all identities, ne? So you should know these, right? So
Yes, ma'am.
we have sine 90 minus x equals to cos x, right? So basically, this is where we just say our sine x, it will be equals to cos x. Sine and cos, they're co-functions. But the only one that's different, it's this one over here, right? And let me tell you why this one it's a negative, so that you don't ever like have to cram them. Because if you cram them, trust me, what if now in an exam you think this is the one that's supposed to carry a negative because you don't really understand what's happening, right? So let me show you why all these three are positive and this one is negative, right? So remember we said um okay, the first quadrant, it's the one year 90 minus x. Then the second quadrant would be 90 plus x, right? So now remember we said sine and cosine, they're what? They're co-functions. So sine, okay, so if we have sine 90 minus x, we know for a fact its co-function is going to be cos x. But now let's look at the sign of the sign. Let's look at whether sign is positive or negative at the 90 minus x quadrant. And if memory serves you well, this is our cast. In the 90 minus x quadrant, Sign will be what? Sign will be positive, right?
Yes, ma'am.
So we're going to have a positive over here. Fine. Now let's say we have a cos 90 minus x equals 2. We know that what is the cofunction of cos? It's just going to be sine x. Right. Now let's go to 90 minus x quadrant, because this 90 minus x quadrant, it's going to tell us about the behavior of cos in this quadrant. Right. Now when we
Yes,
go
ma'am.
to 90 minus x, cos is what? It's positive. So even our cofunction will be positive. So this sign over here, it's influenced by what cos is doing at that particular quadrant. Right. Now let's go sine
Wait, ma'am, wouldn't
90.
the cos be a negative? Oh, no, no,
No,
no,
it's
never mind, never mind, never mind. Sorry, sorry.
exactly. Ne?
Yes,
No,
ma'am.
now we have sine 90 plus x, right? So in the 90 plus x quadrant, it's this one. Okay, wait, before even that, what is the cofunction of sine? It's just going to be cos of x. Now we want to know what the sign of this cos x will be. In order to know, we look at, okay, fine, this 90 plus x, where is it leading us? To the second quadrant, right?
Yes, ma'am.
And what is the behavior of sine in this second quadrant? Sine is what? It's positive. Okay,
Yes, ma'am.
somebody's trying to join. Wait. Um. Okay. Uh. Wait. Yeah. So as I was saying, hi Lisa. Okay, so as I was saying, when you go to the 90 plus x quadrant, what is the behavior of sine? Sine is positive over here, right? So you're going to have a positive. Now we come over here to the cos 90 plus x, right? Equals 2. First things first, we already know what is the cofunction of cos? It's sine x. But now we have to look at the behavior of cos, where at the 90 plus x quadrant, which is the second quadrant. And the second quadrant, what trig function is positive in the 90 plus x quadrant? In this,
Sine.
yes, sine is positive, meaning if we have cos 90 plus x, that cos will be a negative, right?
Yes, ma'am.
Because it's not positive here. So hence this negative is just to show us that the cos, it's negative. The cos at the 90 plus x, it's negative, multiplied by its um cofunction. So you get that.
Yes, ma'am.
Okay. Now we go back to the question. So now we have cos squared 90 minus x. We said that cos squared 90 minus x, what is its cofunction? It'll just be sine x. But notice what's happening. They said cos squared 90 minus x. Meaning what? Meaning we will have sine sine x. Why do we have sine x? Because sine x, it's the cofunction of cos 90 minus x, right?
Yes, ma'am.
Okay, and because it was squared, we just have to square our cofunction, right? So now this will just be simple, because all you have to do is multiply this negative x multiplied by the cos, multiplied by the sine x, which will just give you minus sine x, right?
Yes,
Right?
ma'am.
Okay. Now here, because we have don't yeah, we have a cos squared 180 minus x. So basically what they want us to do is that they want us, if you wanted to, you could just, for now, ignore this 2 and just go and look at the behavior of cos at the 180 minus x quadrant. So how is cos at the 180 minus quadrant? Is cos positive or negative? Please tell me.
Negative.
Yes. Um, okay, because it's going to be this quadrant, 180 minus x. That's correct. Our cos will be a negative. So it means we will have negative cos x. But remember that it was squared. So we'll have a square over here. Damn, let me just write it properly. So we'll have, let me just write it neatly over here. Né? So we'll have minus sine x multiplied by sine x squared minus sine um minus sine x, wait, x multiplied by negative cos squared x. Right, we're
Yes,
here.
ma'am.
We're here now. You can realize that we have a negative here and we also have a negative here. So if we multiply these two negatives, we're bound to get a positive, right? So we're just going to have minus sine x multiplied by sine squared x, right? Um, wait, minus sine x. Yeah, we multiply these negative signs together, then we'll have plus sine x multiplied by cos squared x, right?
Yes, ma'am.
Now, when we look at this, we have a negative sine x, we have a positive sine x, right? Wait, what the hell is happening now? Wait. So we have, wait, we here, yeah, we said negative sine x. Wait, nah, I'm trying to see something here. Oh, yeah. So we have plus sine x, right?
Yes, ma'am.
What we can now do, we can remove a common factor. I think because I'm not writing neatly. Now we are missing all the important things. But if you look at our thing, if you look at our function, we have a common factor. We have a negative sine x here, because this is one term, right? Actually, let's just go back to this term over here. So over here, we can see that we have a negative sine x, right? And we also have a negative sine x over here. So we have what? We have a similar term. Like there's something that we can remove as a common factor from both the terms. Can you see that?
Yes, ma'am.
Okay, so since what we have minus sine x, we can remove the negative sine x as a common factor. What will we be left with? If we remove negative sine x from this over here, what are we going to be left with?
Could you say
If
one?
no, remember, I'm saying we have uh,
No, I
negative,
mean, I
yeah,
mean, since you're taking the negative sign x as a common factor, can't you say like one for the first one?
yeah,
I don't know what to say.
one for the first one. Then for the second one, what will we be left with? Because remember here, what is it?
Negative sign.
No, we already removed the negative sine x. We have
Mm.
negative sine x, right? And sine x squared. If we remove the negative sine x, we're going to be left with the sine squared x, right?
Yes, ma'am.
Okay, so in bracket, if you remove the negative sine x, you're left with what? Sine x squared, which is essentially sine squared x, right? Now, from the second term, which is this one over here, if we removed the negative sine x, what are we left with? We're left with the positive cos x, right? Because we're left, no, positive cos squared x, sorry. We're left with the positive cos squared x. Are you with me?
Ish, no. I don't understand.
Okay, wait. Until uh okay, wait. I think it's because ke kwetse maragaraga, ne? Let me try rewriting the question. So we have sine 180. We're going to run through the first part because we already understand the first part, right? Cos squared 90 minus x plus sine negative x multiplied by cos 180. Okay, 180 minus x in it. 180 minus x squared. Okay, fine. We said, then let me just make a pretty cast diagram over here. Okay. Yeah, fell on trick. This is 90 minus x. 180 minus x, 180 plus x, 360 minus x, right? So we said that this part here, what are we going to do? We just have to look for the behavior of sine where at 90 plus x, right? So we said at 90 plus x, sine will be negative. So hence we had negative sine x, right? Multiplied by. So we said that over here, we have a co-function because remember, if we have cos 90 minus x, it'll just be equals to sine x, right?
Yes, ma'am.
Okay, but the only difference here is that our cofunction is being squared. So which means that when we say multiplied by sine x, our sine x has to be squared. Because we know that the cofunction of cos x, it's sine x. But in this case, the sine x, it has to be sine squared x. Reason being, we also had a square over here in our question, right?
Yes, ma'am.
Okay, now moving on to this. So we have sine multiplied by negative x. So I'm saying this one is going to be relatively easy because all you just have to do is multiply between the two. So we're going to have negative sine x, right? Now let's look at the last term. We have cos squared 180 minus x. So we have to go and look at the behavior of cos where at the 180 minus x quadrant, right?
Yes, ma'am.
So at the 180 quadrant, where is it? It's this one. Is cos positive or negative at the 180 minus quadrant?
Wait, ma'am, what was the question?
Okay, so we're doing this one and it looks like this. It's written as cos squared 180 minus x, right?
Yes, ma'am.
So I'm saying cos at 180 minus x, is it positive or negative?
Oh, negative.
It is negative, right? Because it's
Yes,
over
ma'am.
here. So we will have a negative cos x. But remember, we had a square. It was raised to the power 2. So you have to write it like this.
Yes, ma'am.
Are we fine with this? Now, I'm saying, as we now observe further into trying to simplify, we realize that we have a common factor amongst the two terms. We have this minus sine x over here, and we have a minus sine x over here. So what can we do now? We can remove this minus sine x as a common factor. So if we remove the minus sine x from here, we're going to have minus sine x, right? If we remove it from here, what are we now left with? We're only left with the sine squared x, right?
Yes, ma'am.
Okay. But no, do you understand? Because we removed it from here. Now, if
Mm.
we remove it as a common factor, first time, what are we left with? Sine squared x, right?
Yes, ma'am.
Okay. Sine squared x. Now let's look at the second term, which is this one. If we remove negative sine x, what are we now left with? If we remove this as a common factor, what are we
Oh,
going to be
one.
left with? No, remember, it's this whole term over here.
Oh,
Yeah. So if we remove negative,
uh, ish. You'd be left with the cause.
yes, you'd be left with the cos. But instead of a negative cos, we're going to have a positive cos squared x. Reason being why you're having a positive cos squared x is that um, when you remember you had a negative over here and you also have a negative over here. When you multiply these two together, you get a
Mm.
positive, right?
Yes, ma'am.
So which means this sign, it will now carry the positive sign. So when you remove this negative sign x to the other side, I mean, just to reinforce this, let me just quickly multiply in, just to show you that if we remove it and if we multiply in, we're going to come back here again, sir. So if we multiply in, we'll have negative sine x multiplied by sine squared x, right? And then now if we take this and multiply it in here, we'll have negative sine x multiplied by cos squared x, which essentially this, it's the same thing as this right here. Do you get it?
Yes, ma'am.
Okay, so now let's come back here because here I was just trying to show you, né? Let's come back here. So we have negative sine x, sine squared x plus cos squared x, right? So remember, you said you didn't like you were not attending with us the other day. Under identities, I said we have sine squared x plus cos squared x being equals to 1. This is an identity. This you should know it. So whenever you see sine squared x plus cos squared x, it'll always be equals to 1. Or it could be written as cos squared x plus sine squared x. It doesn't matter really the order, but they will always be all equals to 1.
Okay.
Okay, so can you see that over here we do have our identity? So now we're going to say minus sine x all into what? We said sine squared x plus cos squared x, it'll be equals to 1. So now we just have negative sine x, which is our final answer. Because remember from the initial, from the question, they said simplify it until you are only left with one trig function. Do you understand it?
Yes, ma'am.
Okay. Let's try moving on to 3.3. Right. 3.3. Ne? Okay, so 3.3, they're saying evaluate without the use of a calculator. Ne? So over here, we're going to use what we call reduction formulae. So for 3.3, we have yeah, we have, let me use the purple one. We have cos of 100 multiplied by cos 315 multiplied by 10, 210. You guys can still see my screen, wasn't it?
Yes, ma'am.
Okay, great. All divided by sine 675 multiplied by cos 150 sine 170. Right? So when we use reduction formula, what we basically try to do is show how we perhaps could have gotten this 100, right? So remember, we have from these, we have 90 minus x, 180 minus x, 180 plus x, 360 minus x, right? So if we have 100 over here, we try to find out what operations were performed in order for us to have what? To have 100. So I'm going to take them bit by bit. Ne? So if we have cos 100, it means that we had from these over here, you have to choose one that you're going to work with, right? And remember, if you have 100, where does 100 fall? 100, it falls between the 90 and the 90 and the, what is this? The 90 and the 180 boundaries. So if you have 100, this angle over here, it falls over here. So if it falls over here, you have to choose this over here. You have to choose this operation, the 180 minus x. Again, why are you choosing the 180 minus x? It's because 100, it falls where? In between 90 and 180. Do you get it?
Yes, ma'am.
Okay. So how did we exactly get this 100, right? So we're going to say we had to say cos 180 minus 80 degrees. Isn't it 180 minus 80? It's going to give us 100.
Yes, ma'am.
Okay. Okay. Um, right. Okay, wait a minute. I just need to see the question again. Okay. Okay. So this part you get it, this part you get it, right?
Yes, ma'am.
Okay, fine. So you have cos 180 minus 80, which now is going to give us a cos of this over here, a cos of 80. But again, you have to check what is the behavior of cos where at the 180 minus x part. And if we go back to our test diagram, 180 at that part, at the 180 again, quadrant, cos is what? It's negative.
Yes, ma'am.
So we're going to have a negative cos 80. So, ah, the fuck? Okay, sorry. So if we have, okay, excuse. So we're going to have a negative y because our cos is negative at the 180 minus x part of the quadrant, right?
Yes, ma'am.
So eventually ending up with a negative cos 80. So what we did over here is just we did the reduction method, right? So now let's go to the cos 315. Again, you ask yourself, where does 315 exist? It exists where? In between 270 and the 360 quadrant, right? In the fourth quadrant, that's where you can find 315. And what operations had to be done? So if you have about 315, which it means now you're in the fourth quadrant. And what hello? Okay. And what operations are in the third quadrant? We have 360 minus x. So what did we subtract from 360 in order to have 315, right? So this cos 315, it's similar to cos 360 minus 45. Because if you were to punch 360 minus 45 into the calculator, it's going to give you 315. Do you see that?
Yes, ma'am.
So now we say equals to cos of 45. We have reduced it. So essentially what we're trying to do is reduce the cost from being a very large thing to a small thing. But before you conclude and say that it's just equals to cos 45, you have to go back and look at 360 minus x, because this is essentially 360 minus x. In this quadrant, the 360 minus x, how is the behavior of cos? Is cos positive or negative there?
It's a positive.
It's a positive. Right. Now we go to 10 to 10. Right. 10 to 10. So what operations had to be performed to 10 to 10 in order for us to have 10 to 10? So the first thing that you have to ask yourself, where does the 210 lie? Right? On a quadrant, if you have 90, 180, 270, to 210, it lies somewhere in between the third quadrant, right? Reason being, it's greater than 180, but it's less than 270, right?
Yes, ma'am.
So, what is this third quadrant? What are the operations in the third quadrant? We know that in the third quadrant, we have 180 plus x. So, which means something must have been added to the 180 in order to give us what? In order to give us this 10 to 10, 210, right? So, which means we just have 10 180 plus 30, right? Because if you say 180 plus 30, you have 190, 200, 210, which is what we have over here, right? So you can just say equals to 10, 30, because you're trying to reduce it into a smaller angle. But firstly, you now cannot just say, okay, 210, we're done. You have to check what is the behavior of tangent at this 180 plus 30. So it will be the 180 plus x quadrant. Can you tell me what 10 is like over here?
Positive.
Correct. It is a positive over there, right? So now let's go to what? Sine 675. So now these are the ones that normally try like trick people, right? Whenever we have like very extremely large. So whenever you have like an extremely large angle and it does not fit on your Cartesian plane, because over here the furthest that we can go, it's 360, right? So see, with 675, you wouldn't even know in which quadrant can you find the 675, right? So with extremely large angles, what you can do, you can just say sine. We're trying to, okay, see, we have a big angle. We're trying to reduce it and have it come back into our Cartesian plane in one way, right? So we're going to say 675 minus 360, which is going to be equals to sine. Can you say 675 minus 360 for me?
315.
315. So now we have sine 315, right? Since well we have sine 315 like this, now this is something that we're familiar with. This is something that we can work with, because this 315, it means what? It's located in between 270 and 360. And remember, what are the operations in between 270 and 360? It's 360 minus x. So in order to have 315, we just said sine 360 minus 45. Because if you punch 360 minus 45 into your calculator, I tell you, it'll give you 350.
Yes, ma'am.
Okay. So now we can just say this will just be equals to what? It'll just be equals to sine of 45. But firstly, you have to check what is the behavior of sine in the quadrant 360 minus x. Right? So what does sine, how is sine behaving in this quadrant, in the 360 minus x quadrant?
It's negative.
It's a negative. So you'll have a negative sine 45. Right? So whenever you have like extremely large, like really large angles, you all you have to do, don't be scared, subtract by 360 to try and regulate them back into the Cartesian plane, back into this revolution, back into this circle. If still after you subtract it's still a big number, subtract again by 360. Ne? Why not just be consistent with only subtracting by 360? Don't say now you want to subtract by, I don't know, ne? It should always be
Yes, ma'am.
360. So now we're done with the cos. So with the sine, right? Now we go to cos of 150. Let's check where in the Cartesian plane is 150. 0, 90, 180. 150, it's definitely somewhere over here in the second quadrant, right?
Yes, ma'am.
Okay. So this will just look like this. Okay, fine. So in the second quadrant, which we have cos 150. Okay, so what operations had to be done? Remember this, or the operation in the second quadrant, it's 180 minus x. So what operations had to be done in order for us to get 150? Okay, you tell me. So we said cos what?
Remember, what was your question?
Okay, I'm saying we have cos 150, right? So
Yes,
what
ma'am.
operations had to be done in here in order for us to have cos 150?
Oh, 180 minus 30.
Good. So it'll be 180 minus 30, which essentially leads to what? What's the next step after this?
You say cos 30.
Exactly. You say cos 30, but again, you have to go back and look at the behavior of cos at the 180 minus x quadrant, right? So at the
Yes, ma'am.
180 minus x quadrant, what is cos doing?
It's a negative.
It's a negative. Correct. Correct. Now we have cos 150 minus hi. Hi, so hi, Lisa.
Yes, ma'am.
Can you guys hear me? Oh, okay,
Yes,
good.
ma'am.
So I was saying, walk me through the sine 71. Let's do this one together. How would you do it?
You would say um 180 minus 10, and then
Good. Yeah.
you say sine 10, and then you look at the how it's behaving. Um
Yeah.
ish.
Yeah, you are correct.
I forgot how to look at the behavior.
You just go to the, because this is essentially just this over here. It's essentially just 180 minus x. So you're going to head to the 180 minus
Oh,
x quadrant and check for the behavior of sine. Because
oh, it's
sine is
positive.
negative. Correct. So you have a positive, right? So
Yes,
over
ma'am.
here, I was just doing this just to show you how we can get things over here. Ne? Just how many did we get? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, now let's just substitute them back to our. So we will have, so for cos 100, we got that it will just be, let me just quickly do the substitutions. Minus cos of 80 multiplied by cos of 45 multiplied by 10 of 30 degrees. Okay, now we have, yeah, all divided by what? All divided by negative sine 45 degrees multiplied by the 151 minus cos 30 degrees, right? And multiplied by sine. Are you guys with me?
Yes, ma'am.
Okay. So wait. Then from here, all that you can now just do is punch this into your calculators, right? And then yeah, you'll get your answer. Just throw the whole thing into your calculator, and then you'll get your answer. Um, Wait, did they say without the use of a calculator? 0.3.
Yes.
They said without the use of a calculator.
Yes, ma'am.
Okay. So now, if they tell you that strictly without the use of a calculator, now this is where we have our special angles come into play, right? I
Yes,
don't
ma'am.
know if you remember the two triangles for the special angles. You remember that we have like two very unique triangles in trigonometry. One of them it's a 45. Okay, they look like this, you know? One, it's 60 and 30, right? And then one, it's 45 and a 45. Please write them down into your books, because whenever they say without the use of a calculator, now it means you cannot use your calculator, so you should know your special angles, right? Because this is where you're going to get your answers from. This is one, and this is going to be root. And then we come here. This is 1, and this is 2, and this is root 3, right? Okay, so fine. Um, I'll just come back to this now. right? They are not on our special angle triangles. But this cos 45, tan 30, negative sine 45, negative sine 30. We can just find them where? From our special angle triangles, right? So I'm going to show you how. First row, then the second row, you do it with me. Ne? So we're going to have negative cos 80 multiplied by cos 5. How you 45 by using the special angles? You will go on the 45-degree triangle, this one, and then check where your cos 45 is. Remember, it's so poor. So it's adjacent over hypotenuse. So cos 45 would be what? It would be 1 adjacent divided by root 2, right? So 1 divided by root 2. Right. So now we have 10, 30. We go to what? Our 30-degree angle. Here's our 30-degree angle. Not over here, but over here, right? What is 10 Ghana? 10, it's opposite over adjacent. So it's opposite over adjacent. So it'll be what? It'll be 1 over 2. Are you with me?
Yes, ma'am.
Okay. Um, okay. I just have to read my back. So divided by. Now give me, because we have a negative, give me what sine 45 would be from this, from the 45-degree special angle triangle. What would sine 45 be? Because
It would be
and okay,
square
so
root
it's just what? Opposite.
opposite over hypotenuse.
Yeah. Yes. So what
So
is our opposite over hypotenuse going to be?
1 over square root 2.
Exactly. 1 all over root 2. Right by. Our cos 30 going to be?
Square root 3 over 2.
Cos 30. You said it's going to be root 3 all over 2, which is correct, right? Multiplied by sine of, right? Remember what I said, what cofunctions are. Cofunctions are, okay, this is correct, by the way. This part, incorrect. Remember what I said cofunctions are. Cofunctions are essentially functions that you can add, A and B, and they should give you what? 90 degrees, right?
Yes, ma'am.
So let's say you have cos of um, 45. Its cofunction, it will be cos of 45. Remember, Rona, we've been used to the ones where we just said cos of 90 minus x, it would be, sorry, 90 minus x would just be sine x. Reason why we just had them like this, these are the general formulas. This is just the general formula. But if in fact you do have like a cos of 45, you know that it's cofunction. Basically, um now a function that if you add to it, it will give you a 90. It will just be sine 45. Because if you say 45 plus 45, they're going to give you 90 again.
Yes, ma'am.
Okay. Similarly, if you have sine
Ma'am,
60. Hello?
ma'am, your screen, for me, on my side, it's frozen.
Oh, ish. Yeah. Okay. We're back now.
Yes, ma'am.
So I was saying, Tina, we're used to it looking like this. Cos 90 minus x equals to sine x. But this is just the general expression. If we want to be more exact, we can say cos 45 equals to sine 45. Reason why they're equal to one another, they're co-functions, right? Because if you add the 45 together, they give you 90. So I'm saying now, if you have sine 60, we know that its co-function is cos. What can we add to 60 in order to get a 90?
30.
Correct. 30. Right? So sine 60, its co-function, it's cos 30. Reason why cos 30, it's this co-function is because if you add the 60 and the 9 and the 30, they're going to give you a 90 degrees. You now understand, Mina? Like you understand
Yes,
this.
yes, ma'am.
Similarly, if we come here to this question over here, we have a negative cos 80. In the bottom, we have a sine of 10. Kana, if you're doing expressions, you should try by all means to do operations that will eventually lead to either the numerator canceling out with the denominator, right? So if we have a cos 80 like this and we have a sine 10 like this, we can say that the co-function of this cos 80, what is it going to be?
The what?
The co-function, basically its friend that's going to help us make this 90. What is it going to be? Just apply this. Because remember, we said if we have sine 60, we know for a fact its co-function is cos 30. If we have cos 45, we know for a fact that its co-function is sine 45. So over here, if you have cos 90, cos 80, what is going to be its co-function? Sorry. The co-function of cos, it will always be sine. Ne? Now, all we just have to do is check 80. What more do we need to make this 80 and 90? We just need a 10. So the co-function of cos of 80, it'll just be sine of 10. Remember, cos is the co-function of sine. Hence, we have sine over here. And then the main objective of co-functions is to add up and give us 90 degrees. So if we already have an 80, we should check how can we make this 80 a 90? And then hence we have a 10 over here. Do you guys at least understand why sine 10 is the co-function of cos 80? Now,
It's not
guys,
really, ma'am.
not really, no?
Mm.
Okay. So let's say if we have A plus B, and we know for a fact that they're supposed to give us 90 degrees, we call A and B co-functions. Same way, if we have A plus B and they give us 180, we call them supplementary angles, right? Is it supplementary or complementary? I think it's supplementary. Yeah.
Yeah.
If they're equals to 180, they're supplementary. If they're equal to 90, they're co-functions. And then, in essence to that, cos is the co-function of sine x, and interchangeably, sine x is the co-function of cos. So if we have a cos of 50, what's going to be its what do you call it? What's going to be its co-function? So remember we said what's the co-function of cos? It's just sine. Now that we got that it's sine, what can we add to this 50 in order to make it a 90? We have to add 40.
Yes, ma'am.
right?
Yes, ma'am.
Okay. So, with regards to this one, we have a cos of 80 degrees, right? So I'm saying if you're looking for the cofunction, because if you work this out, this and this will cancel one another, right? Now you'll be left with negative cos 80 multiplied by sine 10. And I'm saying from the cos 80 and sine 10, right? You could just realize that this cos 80, its cofunction is indeed sine 10, because if you say 80 plus 10, it's going to give you 90. And what is the cofunction of cos? It's just sine. So you could, instead of writing it as cos 80, rewrite it as its cofunction, whereby its cofunction is just sine 10. Do you get it? So if we have a cos 80, I'm saying what is the cofunction of cos? According to what we've been saying. The cofunction of cos, yeah, I said the cofunction of cos, it's sine, right?
Yes, ma'am.
Okay, so you're going to write your sine over here, open bracket. What do we need for this 80 to become a 90? A
10.
10, exactly. So this sine 10, it's a cofunction of this cos 80. Do you get it now?
Yes, ma'am.
So if you have a question and you have a cos 80, like we do in the question, right? And then in the denominator, you can see that we have a sine 10. I mean, if you are observant and you're not just rushing through the test, because like I get, you will be able to tell that this cos 80 is its cofunction is sine 10. And if I put the sine 10 over here and we have a sine 10 in the denominator, I mean, we'll have something like this, right? These two will be able to cancel one another out, because we're trying to simplify. We're trying to get rid of as many things as we can, right?
Yes, ma'am.
Okay, so now since well we are deciding that we're going to rewrite this cos x as its cofunction, we're going to have a negative. This negative, it was already there. Ne? Don't think if you have a cofunction, you're supposed to put a negative. This negative, it was already here. So we're going to have negative sine of 10, 1 divided by root 2, multiplied by 1 over 2, all divided, this is division line name, divided by minus 1 all over root 2 multiplied by negative root 3 divided by 2 multiplied by sine 10. Okay, so now when we're looking at this one can cancel out with this one, right? This negative can cancel out with this negative, right? This 1 over root 2 can cancel out with this 1 over root 2. So now, what are we left with? We're left with 1 over 2, all divided by minus root 3 divided by 2. But remember, I said you can just bring this up front and just swap the denominator and the numerator. So now we will have 1 over 2 multiplied by. And now remember, when you bring it up to the top, it is no longer division but multiplication. So you'll have 1 over 2 multiplied by negative. Don't forget. And remember, we said we're going to swap them. So we'll have negative 2 all over root 3. These two will cancel one another. Do you agree?
Yes, ma'am.
So now you'll just be left with negative 1 all over root 3. Right? right?
Yes, ma'am.
Okay. So what time is it? Uh, I feel like I should pause here so that you can try and attempt uh, the second page. Just do what you can do, and where you're struggling, tell me before 8:30 at least. So like the remaining time, try doing paper two, because you have like an ideology, né? Also you listen, né? Please, so that because I mean it's all fun and games when I'm the one doing it, but I need you to also practice, and not just practice anything, but practice based on the papers that I've sent you, so that I can really be sure that you understand. And the beauty about it is that if you don't understand, you can easily just ask me, and I'll tell you that no, here you're supposed to put a co-function, or the reason you're stuck is because of one, two, three. Ne? So please do now, claro, ne? Please do the second page. And then the third and the fourth, we'll do them together again. But the second page, I'm going to have it in these training. Finger. Uh, wait a minute. Please go to the group. I just hearted it. Ne? Okay, I'm gonna reply to it. We did this one. One that's similar to it. Okay, we're going to do. Okay. The one that I said, this one. Please do it because it's similar to what we've been doing. Ne? And then, yeah, from now until 8:30, try doing it, and then send me questions. Ne?
Ma'am, is it the last page?
Yeah, the last page.
Okay.
Okay. Thank you.
Thank you, ma'am.